Okay, guys, thanks a lot. All right. Okay, everyone, thanks a lot for coming along this evening. Welcome. Beers at the back, pizza at the front here if you want to grab it. We're recording this. It's on YouTube to catch up later on if you want. You can share it with people that you know. We generally try and do these broadcasts once in a while. I'd like to do them every month, but it doesn't always work out. A lot of new faces, which is good to see. My name's Simon Waite. I'm the user group coordinator. This evening we're joined by Russ Cam from Elastic, who's going to talk to us about how his experience with using the Azure Resource Manager templating language to do orchestration of deployments in Azure has gone, and some key learnings out of that. I'm sure you're all interested to hear how Elastic has used Azure to do that, which is good. So as you've already figured out, there's always pizza and beer at these events, and we've kind of done that part of the evening. There's still pizza left, and there's, I think, still some beers left back there. So by all means, help yourself when we do a changeover with Russ in a minute. And then we'll do a what's new in Azure since we last got together, which was just over a month ago. It's actually been a pretty quiet month this month in Azure, with Build, all the announcements that came out of Build the month before. Not surprising, probably a few people on summer holidays in the US at the moment. So not a huge amount of announcements, but definitely still some. So upcoming events here in Sydney. Microsoft's running Azure drop-in clinics at the Microsoft store on Pitt Street. There's a range of events out until the end of the year. You can go to that URL. These slides are shared on our Meetup site if you want to go and check that out later, but they're through until the end of the year, one a month. I'm not sure how long they go for, whether they're a couple of hours or an afternoon or something similar, but that's in the Microsoft shop here in Sydney. The Microsoft Open Source Roadshow is in Sydney on August the 7th out at North Ryde, so that's actually being run by me. I'll be running a day of open source on Azure, so we'll look at application development and deployment of solutions using non-Microsoft tech onto Azure PaaS. Look at open source data stores, so things like MySQL, PostgreSQL running on top of Azure Database, which is a new thing that was announced at Build. Continuous deployment into Azure, if you're using things like Bamboo, hosting your source code in GitHub, we'll look at how you do that. And then finally, everyone's kind of subject of the moment, containers. So we'll look at what the container support story is in the Azure environment as well. So that's on August 7th out at North Ryde. There is one in Melbourne on August 11th, if you know anyone in Melbourne who would like to go along. If you go up to my blog at blog.siliconvalve.com, I've got a link up there to go ahead and register. NDC Sydney is in August as well, so that's the week of the 14th to the 18th of August. And then finally, there's this new Microsoft Summit. The two technical days for that will be November 16th and 17th. There are some other days that week at the same summit, but they're more sales partner orientated days. Those two are the technical days. These slides will be up on our Meetup site, so you'll be able to get to them afterwards if you want. Public previews. So these are things that are out there to try in Azure if you want to go ahead and spin them up in your subscription and try them out. Generally, they don't have a service level agreement attached to them, so if you use them for production workloads, you do so at your own risk. But it's a good way to get familiar with what's coming next in Azure and get ahead of the curve, because as we know, these things are changing regularly. I'm sure, Russ, your days are filled with what happened to that button in the portal that was here last time I looked at it. I know my days certainly are, which is why templating things is sometimes a good option, because those things change a little bit less often than the user interface. Azure SQL Database. So if you do a lot of work with that, temp tables are probably a fairly common idea for you. You now have the ability to have database scoped global temporary tables, so you can create multiple user connected sessions to the same as your SQL database, and you'll be able to access temp tables, so it's no longer scoped to just a single user session. You're able to do that across multiple user sessions, which is useful if you make heavy use of temporary tables. Resumable online index rebuilds, so you've got the ability to stop index rebuilds because they obviously take a lot of resources. Previously, if you stopped them for Azure SQL Database, when you hit start, it went all the way back and started the re-indexing process from the very beginning. This allows you to pause an index rebuild and then to resume from the point at which you paused it. So if you've got a very large set of tables that you're wanting to re-index, obviously you're going to get through those a lot quicker without having to go back and start again from scratch. Azure SQL Data Warehouse in preview, so they've done some work to improve performance, so you've got a 3 times compute boost in running your data warehouse services. And they have what they've termed unlimited columnar storage. Unlimited usually means some number larger than you can probably ever hope to provision. The reality is there probably is a finite limit on that. If you do ever hit it, please let me know and I'll update what unlimited actually equates to. Having worked in Office 365, we've seen unlimited storage in Office 365 sometimes top out at about 180 gigs, but they get taken out fairly quickly, those limits, but you do hit them occasionally. So when we use the term unlimited, it's usually just a number larger than you think is possible to use. But I guarantee you there'll be someone in the room that would use it. It's always a possibility. Azure Network Watcher connectivity check. So this is about allowing you to figure out what's going on in the VM, see why it can't talk to something else, and actually go and run some tests on it to figure out why you can't connect from that virtual machine to somewhere else, or why you can't connect from somewhere else to that virtual machine. It's kind of one of those black box areas a lot in cloud environment, is telling you what's going on at the network level. Packet sniffing and all those sorts of things generally aren't an option for you in these environments, because being able to put virtual network interface cards into like a promiscuous mode to sniff traffic is generally not a good idea in a multi-tenant cloud environment. So we're starting to see a lot more of these kind of management type services come out in the forms of Azure Network Watcher, Azure Security Center, and those sorts of things. So this is a new service which is just a connectivity check, which you can go in and configure to say, well, do a trace from this host over to that address and tell me, you know, where it went, what the packets were doing, those sorts of things. Also good if you're putting a lot of virtual firewall appliances into networks, which a lot of larger corporates like to do. They like to make lives difficult for us developers. And then service health. So this is a customized service health just to your subscription. So you get like an overview of what's going on in your environment. There's actually a video which I'll play at the end of this bit that covers what the service health service offers you. It'd be interesting for you guys to have a watch of that. It doesn't go for long. Generally available. So these are services you can go and spin up today, put your hard cash down for, and get a service level agreement attached to it, so you can run production workloads for these. Azure Site Recovery, we've seen some good small changes from those guys over the last couple of months. Anyone that's using Server 2016 or storage spaces, you now have the option to back those items up to Azure Site Recovery, so you can actually use those as sources for data and back them up into an Azure Site Recovery Vault, and then recover them out into Azure if you want to. And they've dropped Ubuntu support as well, so that's now a natively supported target from on-prem workloads to being backed up into, or being recovered into Azure, I might add. So difference between site recovery and backup. Backup just gives you a vault, very much akin to backing up to a tape in a traditional data center. Site recovery actually allows you to back up and recover to a virtual machine running in the Azure cloud. So you can configure Azure Site Recovery to run primary site as your data center, secondary DR site as Azure, and then you can actually do a failover event between those two environments, and that's coordinated for you by Azure Site Recovery. So the more support we see for that, the better it is if you're wanting to run a hybrid cloud environment in your business. Accelerated networking. So this is the result of all of the field gateway array work that Microsoft's been doing. It's allowed them to speed up the network connectivity that's available to the virtual machines in Azure Cloud. So if you go and spin up I think it's 8 CPU virtual machine or above, you get access to a virtual network connection up to 25 gigabits per second, which is the fastest network connectivity of any cloud provider that's out there at the moment. So if you've got a lot of applications that are network heavy, running up a machine with RDMA support and the kind of right networking interfaces built into it, you can get that 25 gigabit throughput, which is really good for those high performance compute scenarios. That's generally available for Windows at the moment, and the Linux support for that's currently in preview. So good if you're a person that uses a lot of IaaS. Azure Relay Hybrid Connections. So this has been around for a while in one form or another. It was tied to the old port and the old service bus implementation. The downside of it was that it relied on Windows Communication Foundation, or WCF, to do a lot of its magic to cut through corporate firewalls. The new implementation of Azure Relay Hybrid Connections, wish they would shorten the names of some of these products, makes it hard to say, Doesn't require WCF anymore. So I think the target for that is going to be that it'll be cross-platform, so you'll be able to stand that up to connect regardless of what OS you're running. And then Event Hub's capture. So this has been in preview for a while. It was originally called Archive. What it allows you to do is, Event Hub is a bit like Service Bus. The difference being is Service Bus, the default behavior for Service Bus is when you read a message off of it, it's popped off the bus and it's not there anymore and you can't reread it. With Event Hubs, when you read a message by default, it's left on the hub. You can go back and reprocess those messages. You can do time-based, series-based type processing of Event Hub messages and leave them on a hub for, I think it's anything up to like 30 days if you want to. With Archive, you can basically set a policy that any message that stays on the hub for more than a certain amount of time will be archived off to a storage account in an Avro format that you can then push through Hadoop if you want to do analysis on it. So that's now available for use, but they've renamed it. They called it Event Hubs Capture. So that's pretty cool if you want to do a large amount of, say, IoT throughput and you just want to archive that stuff off, you just write that all onto an Event Hub and then use Archive to write it into storage for later. Announcements. Azure Stack can now be ordered. Who knows what Azure Stack is? Yeah, oh, okay, a few, good. So as of last week, with Inspire in Washington, Microsoft announced availability of rack pricing for that from the likes of Lenovo, HPE, and Dell. So I think it starts somewhere in the region of about $150,000, depending on the size of the rack that you buy and run those puppies on. If you've used the old cloud platform service, CPS, that was sold by the likes of Dell, it's packaged very similar to that. The slight variation is that you can either choose an all-you-can-eat licensing model where you basically can install as much of that in your data center as you like and not pay anything to Microsoft beyond that money down up front, or you can use a PAYG model where you pay effectively for the hardware and some core licensing, and then services like app service or virtual machines and the IaaS and virtual networking, you pay a consumption-based licensing model to Microsoft for that. So they're bringing that Azure PAYG model into your on-prem data center if you want. Going to be interesting to see where that goes. It's been, you know, in preview and in public versions and technical previews for about 18 months. Microsoft's putting a big bet on that, so we'll see where that goes for them. And there's no one else in the cloud space that's got that offering at the moment. AWS doesn't want you to go onto the on-prem world, right? They want you to come into AWS if it's not. Sorry. OpenStack, yeah. Well, interestingly, you can run some of those types of workloads like OpenShift. You can actually run them on Azure if you want. It's not quite OpenStack per se, but you've got some options around that space if you want to run that in your data center and on a cloud platform. You know, IBM has been looking at OpenStack. I think they've gutted a lot of their OpenStack practice just recently. So who knows where OpenStack is going to go. Problem with that is you then need to build the in-house expertise to run and manage an OpenStack platform.
Sure.
Yeah.
I guess alternatives, right?
Yeah, absolutely. Yeah, you know, it's all good. You know, we need choice and competition because it keeps everyone honest. If there was only one person out there, none of us would be sitting in this room listening to me talk about Azure. They'd probably be down the road talking about AWS. No, I'm just joking. And then Azure SQL database, as of the 1st of July, you can no longer manage it via the legacy portal. It's only via the new portal. So I suspect over the next year, we're going to start to see most of the services start to announce that. And hopefully by the end of next year, the legacy Azure portal will be a thing of the past that no one remembers, but everyone mourns the loss of because they don't like the new portal. Although the new portal has gotten a lot better. There's actually some really interesting engineering that sits behind that. Anyone play with Cloud Shell?
Yeah.
Yeah, so Cloud Shell is a Bash or PowerShell based console right in the web browser. So you pop it open, you can run Bash scripts or PowerShell scripts right there in the browser, execute templates without having to install anything on your machine. And that's been driven out of a Kubernetes-based infrastructure that's been stood up in Azure to deliver that. If you've worked in GCP before, Google Cloud Shell would be something that's familiar to you. This is a variation on that. Very cool and very powerful if you want to have a look at that. That's me. So we're going to do a quick, that's not me, that's Russ. We're going to do a quick technical changeover. So if you need to take a visit to a toilet, it's that way. If you need some pizza, it's over there. If you need a drink, it's at the back. We'll take, let's say, 5 minutes just to do the changeover. Thanks a lot, guys, and talk to you later.
Thank you.
So, over to Russ.
Cool. Thanks so much, guys. Hope you've managed to grab some food and grab some drinks, and let's kick it off. So yeah, thank you very much for coming along tonight and hear me rabble on about my experiences building ARM templates. Hopefully, it'll be useful for you. So a little bit about me. I work at Elastic, so we're the company behind Elasticsearch, Logstash, Cabana, Beats, set of open source products for being able to visualize and manipulate and search your data. I work on the Microsoft team there, so we're responsible for a few different things. The .NET clients is one of them. We also just released the first version of the Elasticsearch MSI installer, so we've now got a native installer for Windows. Should make it much easier to install Elasticsearch Windows and get started. And then the other thing that I'm going to be talking about tonight here is we also work on the ARM template. So we were a team of 3 people. We went down to 2 people. We're now back up to 3 people. So 3 people are looking after all of this stuff. So yeah, the Azure Marketplace and ARM template is what we'll be looking at tonight. So how many of you are familiar with the Elastic Stack or Elasticsearch or have used it before? Okay, there's a few of you. Okay, that's cool. In production as well? Sweet, awesome. Okay, I'm going to give a very brief overview for everyone else's benefit. So the Elastic Stack is really a set of open source products from Elastic. So at the top there, we have Cabana, which is a way of being able to visualize all of your data, build nice dashboards, graphs, that kind of stuff. So that's like a web application. Then you've got Elasticsearch, which is kind of the engine that powers everything there. So it's a very powerful search and analytics engine, which I'll talk about in a second. Then there's kind of a couple of ways of being able to get data into Elasticsearch. So one of them is Logstash, which I think of as kind of like a centralized ETL pipelining tool. So you define a set of inputs, define a set of collection of filters, and then a selection of outputs. So you can bring data in from various different places, Kafka, Elasticsearch, from files, et cetera, transform it in some way. So you can do things like, given an IP address in the source data, go and get the GeoIP location data, so the country code, where that person's located, and then filter, send that to some output. One of those places being Elasticsearch. You can also send it to Kafka or SQS or Azure Q Storage or pretty much wherever you want to send it to. And then Beats are kind of super lightweight data shippers. They're kind of built around the Unix philosophy. So it's kind of do one thing and do it well. So whereas Logstash is kind of like a centralized pipelining tool that you sort of manage in one central location and send things to it. With Beats, you'd actually run those on the edge nodes. So for example, if you're running web servers with IIS or you're running Apache, you might have, for example, FileBeat on there, which is able to look at a particular directory and take the Apache logs or the IIS logs and tell those logs and then send them to somewhere, one of the places being Elasticsearch. So you can do some really neat things such as take a particular log line, send it to Elasticsearch, and then within Elasticsearch, there's something called ingest, which you can then split down that log line into individual elements, build a JSON document from it, and then send that into Elasticsearch. On the right-hand side there, that's our commercial offerings that extend the open source offerings there. So we have things for around security. So things such as OAuth, like role-based access control, document-level security. So these people can't see these, PII-sensitive particular fields in documents. Alerting is being able to say things such as, given a set of documents coming through, I want to run some particular function to run and then send an alert to someone, say, via PagerDuty or Slack, or send an email when some kind of situation or event has happened. Monitor exactly what's going on in the stack. Graph, being able to understand connections between documents. And machine learning, which is unsupervised machine learning to detect anomalies within your data. So this is kind of geared towards time series data. So if you're looking at bringing in logs or metrics into Elasticsearch and you want to sort of understand the anomalies, some anomalies you can easily eyeball, but there are some things which are anomalous which you cannot easily detect by eye, and that's kind of where machine learning comes in. So that's kind of a brief overview. Elasticsearch itself is exposed as a REST API, so you interact with it via JSON over HTTP. So you send in JSON documents, you get JSON documents back, or you get JSON results back. So everything is JSON-based. And there at the bottom is Elastic Cloud, which is basically our Elastic as a service offering, which incorporates Cabana, Elasticsearch, and the XPack stuff there in a one sort of per monthly fee there. So kind of a brief overview of Elasticsearch. I'm not going to go into loads of detail because we could spend probably 3 hours talking about this stuff. But a very, very brief overview. Elasticsearch is a distributed real-time system. So you run the system over a collection of nodes. You can spin up a single node, you can spin up 2 nodes and have them form a cluster and then distribute data and queries across those 2 nodes. So in this particular scenario here, we have 3 nodes, and when we index our data within Elasticsearch, it goes into an index. We can think of an index as spanning across those particular nodes there. And within this particular index here, we have 3 shards, 3 primary shards, which are denoted by the P's there. So that data is now going to be distributed across 3 shards, across those 3 nodes, and overall that forms like an index. But what we also have here as well is we've actually replicated that data to a set of replica shards as well. And what that means now is, similar to other distributed systems, if we were to lose 1 node here in this cluster, then this cluster is still going to be operable because we have a complete set of shards for the entire set that makes up the index there. And then what you would end up happening there is that those replica shards would end up being promoted to primary shards. And once that other node then comes back up again, Elasticsearch takes care automatically of reshuffling and redistributing shards across those nodes. That's kind of a really brief overview. Grab me afterwards if you want to go into more detail, and I can certainly do that for you. But we're here to talk about ARM and Azure Marketplace. Whee! And so rather than play this video for you, I'm probably just going to tempt the demo gods and actually see if we can deploy a cluster instead. So hopefully you can still see this. So if we jump into, actually before we do that, very, very brief detour. This is Cabana here. We have a couple of pre-built dashboards. So this is from our collection of demos that we kind of go around and show people. This particular one here is just looking at earthquake data. So one of my colleagues over in Japan took all of the worldwide earthquake data, which is openly available, has indexed that into Elasticsearch, and then using Cabana, they've built a collection of visualizations, and they've put all of those visualizations together here to form a dashboard. So we can do some really cool things, such as if we just want to look at this particular area here, hopefully we're still logged in. Yeah, we are still logged in. So we noticed that every other visualization here then changed metrics. So they're all completely related, and they're all looking at the same particular set of data. And this can also be time-based as well. So if you're looking at logs or metrics coming in and you want to look at the last 15 minutes, this is going to be updating real time, and we can look at a particular span there. If I have a date histogram, for example, and I want to look at logs between here and here and look at all of the metrics for that, then we can, select that and then look at those things. But he's made some handy shortcuts here, so we can go and have a look at Japan and look at all the seismic activity around Japan. And yeah, we can look at some graphs there for things like count per magnitude, depth series here, Japan foreign direct investment net inflows. That's a new one in there. So could potentially be tied to earthquakes going on there. That's kind of one example. Another one here is US domestic flights. So those going in, those coming out, delays and arrivals. Looking at average delays per type here on the right-hand side. So yeah, due to NAS, I'm not sure what that is. I don't think that's the wrapper. Late aircraft, so yeah, carrier, so carrier's fault here, security. But we can have a look at all of these other different metrics here. And this is just, again, this is just using openly available data. Both of these examples are dealing with static data, so this isn't updating in Elasticsearch on the back end, but it kind of gives you a flavor of the kinds of things that you can do. The thing I wanted to show you here was the marketplace. So the Elasticsearch ARM template is available in the Azure Marketplace, which is a third-party kind of container in which third parties can put templates that they've built, and everyone can go and deploy from there. So if we were to go here and look at new and search the marketplace and look for Elastic. Yep.
So feed's still showing that view.
Ah, okay.
So I'm not sure which one it's looking at.
Let's have a look at.
Probably still thinks it's extended.
Right, okay, 1 second. That's okay. Just having a few technical difficulties here. We should be back on our way in a second. I stop sharing and reshare again. Let's give that a try. Okay, let's try sharing the screen again. Fantastic. Excellent. Okay, let's. That's okay. So we're back in action now. So yeah, if we were to go to the marketplace and search for Elastic, this first one here is our template, and we can go through here and we can go through all of the steps to go and deploy an Elasticsearch cluster. So this is kind of a step-by-step wizard. So we can go through and fill out all of the details here. So put in a password for the machines. So this, if I need to log into the VMs, this is the username and password that I would end up using. So let's have a look at building Sydney Azure. No, we don't want West Europe. We want Australia Southeast. And we can step through here.
Could you zoom in?
Yeah, sure. Yeah, so let's zoom this one up a little bit. There we go. So name the cluster, configure the subnet for this and the VNet. So we can choose to deploy into an existing VNet if we have other resources that we want to connect this to. And then nodes configuration, how many data nodes we want to deploy. So let's just go for one right now. Are those data nodes master eligible, or do we want to actually deploy master nodes as well? So master nodes are responsible for maintaining the state of the cluster. They don't contain data themselves. They just coordinate the state across the cluster. But for this particular scenario, yeah, let's just deploy that data node as a master and make it master eligible as well. No client nodes. And here, let's just use this super secure password that I've saved from earlier.
And how do you decide that how many nodes we need? How do we come to that conclusion?
So we have a few resources available on the Elastic site for determining that. But that's a very, very open-ended question because it depends on so many different parameters. But we can have a chat about that afterwards. Do we want to install Cabana? Yes, we do. We only want an internal load balancer, so Cabana can only connect to this. We can't connect to Elasticsearch itself from the outside. That's absolutely fine for these demo purposes. My company and my email, that's me, I promise. And fill in these other details, and we're in Australia.
Is it hard to expand on the nodes after that?
No, and we'll go into that. So let's just make sure we get this deployed, and then we will carry on.
This is your handiwork?
This is my handiwork, yeah. So I'll explain how this fits into ARM templates in a second. So yeah, we've read the terms and conditions. There's nothing nefarious in there. I would like to purchase that. Fantastic. So that one's now deploying. Here's one I've prepared earlier in true cooking fashion, cooking show style. So if we just have a look at this one that I deployed a couple of hours ago, we can see the resources that have been deployed here. And if we have a look at the Cabana IP address and take this particular one here, and if we go to the web and we go to port 5601, here we go. We're logged into Cabana, and we can have a look here. So we can go into the dev tools here, which just gives us a basic kind of editor, similar in many ways to like Azure Shell. This is kind of Elasticsearch Shell. This is the shell for interacting with Elasticsearch. So we can issue a GET request. We can have a look, see if there are any indices in here. So have a look, cat indices. Whoa, sorry, I misspelt it. Cat indices, there we go. And we've got a couple of indices already in this cluster. So that's kind of what you get deployed. That gives you a few examples of the kind of things you can see in Cabana. So if we just jump back to the slides. Okay, so everything that you saw there in the marketplace is driven by a JSON file here. So the marketplace UI is completely driven by this declarative JSON. Yep. Yep.
Apologies, guys.
No problem. So from current slide. Aha, yep, there we go. From current slide. Hopefully you can see that.
I think you'll need to undo what you did before, so go into the browser, the session, unshare, and then.
Okay, just 1 second.
Sorry to interrupt you.
That's okay. So we seem to have lost where Hangouts is running. So I've managed to be able to close it down. Yeah. Okay. Let's. Okay. Let's try this instead. So if we go back to. So let's just take that off there a second. Apologies, guys.
It's any problem when you use a browser-based screen sharing application and you need to use a browser. Invariably, you end up closing the browser at some point.
Yeah. So there's a tip in there. Don't close the browser, guys. Okay. Here we go. So I will close that one. We will agree to this one, and
Sorry, mate, I appreciate
no,
it.
you're okay.
It's disruptive, and it's maybe the presenter. I can do it if you want to say.
Yeah. Okay. Sure. Cool. We have. Yep.
Can you go back to the voice to see?
Yeah, we're back in action. Cool. Okay, yeah, so everything you saw in the marketplace there is driven by a JSON file there, which kind of basically has three parts to it. There's basics, which was the first blade, as they call them, that you could see, so like VM details, that kind of stuff. And then steps define the other blades that you have there. And then the outputs of the marketplace UI actually feed into the ARM template, which is the thing that we're going to talk about next. So you can actually deploy to Azure via the portal and use the UI definition, or you can deploy via the CLI or PowerShell or CLI version 2 and go directly using the ARM template and deploy to Azure. So there's a few kind of things related to marketplace templates. If you do end up building them, there's a few kind of caveats to them. Like you can only deploy them to new resource groups. You used to, in the very beginning, be able to deploy them to existing ones. I know in the last couple of months, they've changed that now again, so that you can deploy them again now to existing resource groups, but that existing resource group cannot have any other resources in it. So you can deploy to an empty resource group now. So there's a bit of backwards and forwards going on there, but this is a limitation only of the marketplace UI. This does not limit the ARM template, which we'll talk about in a bit. There's no easy way of doing cross-property validation. So if I put my username in as this, I can't, limit this other input in some other way. That stuff's kind of limited right now, but they are building, Microsoft are building new inputs all the time for these things, which kind of leads on to the next thing, the available elements there. There's some things that are very, very easy to do, and if they have a particular control for doing the thing that you want to do, fantastic. If they don't, you're probably going to end up building it yourself out of basic inputs and doing some other magic to wrangle that stuff together. And then the other thing, which is kind of a pet peeve of mine, is that there's no kind of real integrated contact details for this. So you saw in there that last step where we had to fill out all the details. That's part of our marketplace UI template. There's no way of being able to get those details from Microsoft themselves, although that you can get those insights in other ways. They do provide other details, but often it's useful to know, who the actual logged in person was, what their details were, because, people do share accounts and do this kind of other things as well. So that's kind of marketplace stuff. So Azure Resource Manager, so ARM, not to be confused with the chips. It kind of came about in 2014. So if anyone has been using Azure for quite a long time, you always had the classic deployment model. ARM came in around 2014, and it was basically I see it as Microsoft's move to make infrastructure as a service much more consistent on Azure. So everything's under consistent namespaces. So if you want to go and find storage accounts, they're under Microsoft.storage. If you want to go and find stuff related to networks, so interface cards, that kind of stuff, VNets, subnets, it's all under Microsoft.network. And with ARM, you can deploy those resources get deployed into one resource group, and a resource group is tied to a location, an Azure region. But the actual resources that get deployed into there can live in different regions. They're not tied to the same region as the resource group. Confusing, huh? Often, most of the time, from what I have seen, people generally also deploy the resources to the same region as the resource group.
I have one spanner to throw.
Yeah, yep.
You can now deploy resources to multiple resource groups.
Yes, yes,
Yeah,
you can.
It's not quite sure why you would ever do that, but it's not.
Yeah, so yeah, the world is a mess. So yeah, so how would you actually go about using ARM? So you can use it from the command line. Here's an example with the Azure CLI. So at the top here, we go and create a resource group, and then afterwards we go and create a VNet in there, and we pass a couple of properties for creating that VNet. And then we can keep going, and we can build other resources, and we can chain them onto resources that we've created. And this is kind of like an imperative kind of way of building up a bunch of resources within a resource group. But actually, there's a much better way, and this is where ARM templates come in. So we can do declarative deployments with ARM templates. So again, similar to what we saw with the marketplace UI, we can define a JSON file that says, here are the resources that we want to deploy. So in this particular example, this is exactly the same as what we saw before. Again, we create the resource group, but then all we do for the second step is just say deploy the resources from this particular template, and we just give it a URL for where to find that template. And then step 3 is profit there. And yeah, just kind of give you an overview of the stuff that gets deployed with the Elasticsearch ARM template. So there are a few things that are optional here, but to kind of give you an overview of what gets deployed, you can deploy basically a 0 to X size Elasticsearch cluster, X just being limited by the number of the core quota limit on your subscription. So if you have ring someone up and have a nice conversation with them, they will give you an unlimited size subscription if you want that 1,000 node Elasticsearch cluster. So it has the ability to deploy dedicated master nodes. I won't go into the details here, but with dedicated master nodes, we can deploy 3 dedicated master nodes there for you. And 1 to N data nodes, these are actually going to store your data. And then 0 to N client nodes. Client nodes act basically as smart routers. They know where to send particular traffic within the cluster. And then Cabana to be able to visualize everything. And then you've got a couple of options there for external access to Elasticsearch as well. So you might look at it through Cabana, but then you might also want to interface with it via a client like Python client or .NET client, or some other client. So you can either use application gateway, which gives you the option then to secure that with HTTPS, or you can use an external load balancer. Then on the right-hand side, if you decide you don't want to deploy Cabana, we have the option to deploy Jumpbox there as well. So if you need to actually SSH into any of the Elasticsearch nodes that form that cluster, so they're only on the internal network, so they're not publicly available. But if you do need to get to them, you need some kind of Jumpbox. You can go through Cabana, or you can go through the Jumpbox and then SSH into those if you need to diagnose things or run something on them. And we can set up a VNet, and we also set up an internal load balancer there as well. So there's quite a few different topologies here, and we'll see how that plays into building out a template. Quick note about deployments. They're transactional-ish, which means that they either succeed or fail in their entirety. But if they do fail at a particular point, any resources that have been deployed up to that point are not rolled back. So you will still need to go in and clean up that resource group and clean up those resources. A couple of deployment modes. So this fed into the question that came earlier around, can I go and redeploy and scale up a cluster? Yes, you can, because the template that we have is incremental, which means that you can redeploy the same template onto an existing resource group and use that as a way of scaling up an Elasticsearch cluster. The other one is complete there, which basically, as the name probably implies, deletes the resources in that resource group and overwrites them with any newly deployed resources. So if you're interested in having a look at ARM templates and you want to get started with it and you want to look at building your own, Microsoft actually has this ARM Quick Starts Templates website, which is linked to a GitHub repository where they have like hundreds of different examples of deploying various different Azure resources. So it's a really good way of, if you want to understand, well, how do I do this thing within ARM, or how do I do that thing, go and have a look at these, and it will give you a good idea of how you need to do stuff. So once you've got your ARM template, once you've got your marketplace template as well, if you're going to be deploying to the marketplace, you'd actually bundle all that stuff up into a zip file, and then you'd upload it into another portal, which is the publishing portal. And what you would do there is you would go and register for a company, have a nice chat with someone from Microsoft and say, yeah, we want to go and publish a template. And you'll get access to this where you can go and define that template, and you provide various resources, and then it will appear then within the Azure Marketplace for you. There's a couple of fun things with the publisher portal, though, which I really think are worth calling out. You go through this approval process. So when you're building out a template, you first deploy it to a staging environment and link subscriptions to have access to that staging environment. And then you can go and have a play with it. And then when you're happy with it, you can say, yeah, I think this is good enough for production. Click the button, and then you are waiting. You're waiting for someone from Microsoft. I know his name. His name is Simon. You're waiting for Simon to be around, and Simon will have a look at it and he'll say, yes, that's great, or no, that's you need to change this. But sometimes that's days and sometimes that's weeks. Another thing to be wary of, if you are using the Quick Start templates as a guide, there are different best practices for the Quick Start templates versus Marketplace templates. Just something to call out there. And communication sometimes can be a little bit lacking with this. So the Elastic template originally used a Ubuntu image that released by Canonical, which was pulled from the Azure VM image gallery, but there was no notification to go out to any other ARM templates that might have been using that VM image, even though we might know all of the templates that are using that image. There was no notification that went out about that. So all these templates broke. And then we found out afterwards that it had been pulled, but not in every region. So in some it worked, in others it didn't. So we definitely had to get our Sherlock Holmes hat on there to figure out that one. Yeah, and just the last point there, being able to deploy to existing groups, then it was removed. Again, no one said anything, but you know, you find these things out. So on to template development. So that was all Marketplace and like an initial overview of how Marketplace fits in with ARM template. So if you're going to build an ARM template, what does it comprise of? So it's kind of really these four sections: parameters, variables, resources, and outputs. So parameters, as the name implies, it's stuff that someone's going to feed into your template. So you have various different types here, and then we can use these. Parameters within our resources. So here we can provide the ability for someone to name the VNet as it comes in. Pretty straightforward. Next one is variables and functions. I like to think of variables as kind of like the scratch pad of where you can manipulate stuff that comes in and maybe have some defaults and kind of manipulate stuff and change it before you pass it to resources. So these things are like these things are also like a one-time process as well. So once parameters are done, once the variables are done, if you need to manipulate something again afterwards, you're going to have to do something else, which I will tell you about in a second. But here, yeah, we still allow someone to pass in the VNet prefix, and then we just take that prefix and then add it to the unique string that we build from the deployment and from the resource group. And then we use that as the VNet name. So this is kind of useful to do this kind of thing for storage accounts that have to be globally unique. This is the kind of thing you generally need to do. Which brings me on to link templates. So with link templates, you can define all of your resources in the one template. But often you might not want to do that. If you've got a fairly complex template like Elasticsearch, then yeah, it's going to be very, very difficult. And there's some reasons why you don't want to put all of your resources in the one template as well, which I will explain. But you have an ability to call out to another template here as well. And that other template is going to have parameters, variables, resources, and outputs to it. And the outputs for that template are then going to be available in the template from which it was linked. So here's an example of linking to a network, create network template. And then finally, outputs. So you've deployed some resources. We might then want to get some information out of the resources that are deployed. So for example, for a public IP address, we might want to get the fully qualified domain name out of that as an output, because if maybe someone's calling us from the command line or they're calling it from the portal, we want to give that domain name back to them so that they can then use that for some other step in their automation process. So here, all it's doing is getting the public IP address here. It's using the functions that are available in ARM templates to go and get that, and then it's just concatenating it with a couple of other strings here, which are specific to Elasticsearch. So port 9200 is the port that Elasticsearch runs on. So yeah, with outputs, there's something worth mentioning here as well, is that if you have a template that has a link template, that link template has some outputs, you can get those outputs from the link template in the outer template, which you might want to do because you might want some other way of manipulating those, maybe passing them back or doing something else with them. And resources themselves in that way. So yeah, I pulled this face a few times. probably want to do some automated testing on your template as well. Up here at GitHub Elastic Azure Marketplace, and You get to see how many passwords